There. So let's say I go all over the planet, all 7 billion people, and ask them how much you love Batman. And there are people going, I've never even heard of Batman. I live in Sri Lanka, right? I don't know. Not that I assume the Sri Lankans have never heard of Batman, but maybe there is a place in the world that has never heard of Batman, right? And so there's some people who've never heard of him, so they're like, I don't know. But let's say this would be the population distribution, right? Each value in here would represent one person. Tell me how much you love Batman. But now let's say I grab one sample of, I don't know, 36 people. Tell me about the sampling distribution of the mean now. Let's say I was going to grab an infinite number of samples, each with a sample size of 36. The central limit theorem tells me 3 things. What does that central limit theorem tell me?
Mean distribution.
Okay, so what is going to be the shape of this infinite number of averages?
Normal.
Do you think writing normal on the exam will give you full credit?
Maybe.
Well-shaped.
Kidding.
You probably should tell me an infinite number of averages, as long as there's at least 9 in each average, is going to be normally distributed. In fact, it gets more and more perfectly normal as sample size goes up. For example, if I grabbed 100 people, that would be even more perfectly normal. But I showed you with those pictures in class, right? Once we hit about 9 people in each average, that looked pretty darn normal, didn't it?
Yeah, it is.
Right? So it's going to be normally distributed. That's one thing. So what else is this? Tell me what else does the central limit theorem tell me about this sampling distribution of averages?
Standard deviation of
Standard error.
It will tell me what the standard deviation. So now I've got this normal distribution here of averages, right? Okay. So what's the second thing that the central limit theorem tells me? It's going to tell me what?
It's a distribution of
Pardon?
the average.
the average is equal to the average.
That's right. So the second thing the central limit theorem tells me is that this sampling distribution of averages is going to have an average, right? What will it have an average? What will the average of a bunch of averages be? Whatever mu is. In this case, what number?
4.2.
4.2. It'll also tell me what? Let me move back to 36.
We'll have the same as the population average, is what you're saying.
Well, yeah. That's the second thing the central limit theorem tells you. What's the third thing that the central limit theorem tells you? What's missing from this graph?
Standard deviation.
Which would tell me, then I could then, because I need the numbers at the bottom, don't I?
Yes.
Which is called standard error, because the new name we give to the standard deviation of a sampling distribution is what? Standard error. Because it tells us how much each sample average is in error of that population average 42. It's the standard amount of error. It's the standard deviation of a sampling distribution of the mean. It's called the standard error of the mean. Right? And so what is it equal to? So it's going to, so the mean of lots of x bars equals mu, right? So second thing, that's how I would say it in my own words, but I would probably want to use more formal language and proper language if I was taking an exam. So what's the third thing? It tells me about the variability, right? It tells me that the standard deviation of a bunch of averages will be equal to this thing called standard error, and how do we calculate it?
Standard deviation over
square root
This is how you calculate standard error. Can I do that now?
Yes.
Yeah. So it was 0.5 rather, and I divide by the square root of 36, which is 6, right? So who can tell me what standard error would be in this case? 0.08. Could I write these numbers in now?
Yep.
Yeah.
I sure could. So one standard error away would be 4.28. Do you see that? Because I'm adding one standard error to 4.2. One standard error away. Yes?
So the relationship between the standard deviation and the standard error is that they're exactly the same.
Well, I would never describe it that way as you said it, because is it any standard deviation is called standard error?
No.
No, just the standard deviation of what?
sampling distribution.
A sampling distribution of the mean. So the standard deviation of a bunch of averages is called standard error. Does that make sense? Very specific. But it's a really important distinction. We would never say that the standard deviation is the exact same thing as standard error, or we wouldn't give it another name, right? We call this variability of raw scores, we call that standard deviation, because that's on average how much each person deviates from the average, standard deviation. But standard error is how much each sample average is in error from the population average. And this is how you calculate it. So let's say, just like in your homework, you're working out this problem, you know the average, the standard deviation, the sample size, and I say, please tell me standard error. Can you do it?
Of course.
That might also come up on the exam. Right? Okay. So, so tell me, the shape of the sampling distribution for this population is what shape? Normal. Because sampling distributions of the mean are always what shape?
Normal.
Normal. As long as n, sample size, is anything greater than 9.
Or equal to 9.
Well, it gets more perfectly normal the bigger sample size. And once you actually hit around 24, you have something that's indistinguishable from perfectly normal, but it gets pretty darn normal even at sample sizes as small as 9 and 10. But perfect normality really starts being achieved right around 24 people. Bam! There's something that has those perfect proportions so that you can use the table in the back of your book. All right, let's see. All right, so then we had null hypothesis significance testing. So null and alternative, so what is the goal of, if I'm a researcher and I'm going to do null hypothesis significance testing, am I interested in sample averages or population parameters? Who am I trying to make a decision about? Parameters. You're always trying to make a decision about parameters, right? And as the researcher, am I usually trying to reject the null hypothesis, retain the null hypothesis? Reject the null hypothesis, right? And every research question that has ever been asked ever has two hypotheses, right? What do we call these two hypotheses?
The alternate and
The null and the alternate.
Right, the null and the alternative hypothesis, and I am hoping to reject the null hypothesis, right, as the researcher. And so I'm going to actually test the null hypothesis, right? Right. And null and alternative hypotheses are created in pairs, and they always have to be what? There's two things they have to be.
opposite,
They have to be the opposite of each other.
mutually exclusive, and mutually.
Yes, mutually exclusive and mutually exhaustive. So here's my null hypothesis. Tell me whether or not this is a good null hypothesis.
No.
It's not a null hypothesis?
No.
Why? What's wrong with it?
Conditions change.
How about that?
Yeah.
That's better, right? How about this? Is this a null hypothesis?
No.
No. How about this? Is this a null hypothesis?
No.
No. How about that?
Yes.
Yes.
It's always set to equal.
How about that?
Yes.
Yes. Okay. So here's my null hypothesis. What has got to be the alternative hypothesis that goes with this one?
It's not equal.
The mutually exclusive, collectively exhaustive opposite. Do you see how I'm trying to make a decision about a population parameter, mu? Yeah? All right. But now let's say I tell you that this is my null hypothesis. What will be the collectively exhaustive, mutually exclusive opposite?
Greater.
Right? Right?
Yes.
This is what's called a directional hypothesis, right? Directionality. And so listen to this research question. I am interested to see if this class is doing very differently compared to some of my other classes in the past, right? I'm interested to see if you guys are doing a whole lot, you're just different, right? What are my null and alternative hypotheses going to be?
Equal and not equal.
Why? What word did I say that tipped you off?
Different.
Different! But now, let's say, I'm not even entertaining the idea that you could be doing worse. In fact, if you're doing worse, I'm just going to consider that the same thing as you're doing exactly the same, right? Right? So, I want to know, because I think this class is doing better. And let's say this class is here. This class. This class. I think you guys are doing better. What are my null and alternative hypotheses? So what should we put here? Greater than, right? Because I think you guys are doing better than these other folks, right? And so what would be the null hypothesis I'm actually going to test? Less than or equal to, as if those two things are not even different. Right? Good.
You could have stuff like this, like A, B, C, D, and then it's going to be like that. We have to pick one. Yeah, okay.
Probably not a ton of those, but I'm guessing that will appear on the exam, right? That would be my guess. All right.
Okay.
All right, so let's also look at something. So, what else? So then we talked about the null hypothesis sampling distribution of the mean. And the alternative hypothesis sampling distribution of the mean. Do you remember that? Remember that? So, let's say the average exam grade historically was 71. The standard deviation was 2. My class, and this class has 36, right? And I want to know if you guys are doing better. Just better, not different, but specifically better. Is it a directional or a non-directional hypothesis? Directional. So my null hypothesis sampling distribution of the mean. What's my null hypothesis? That this is either going to be less than or that you guys are going to have an average less than or equal to 71, right? So the null hypothesis sampling distribution of the mean is going to be centered on what? 71. It's going to have a standard error of what? 2 over the square root of 36, right? 2/3, wait, 2/6 is 1/3, right? Did I do that right?
Yeah. 0.33.
Right? So I can now write the numbers in down here, right?
Yeah.
71.33, 71.66, 70.67, 70.64, 34. Right? I'm just adding one standard error, 2 standard errors. 1 standard error, 2 standard errors, right? And let's say I find out. Now I'm about to get your actual final exam grades in here, right? And I'm trying to determine if you guys do better than average historically. I need to decide ahead of time how far away from 71 your score would have to be in order for me to reject the null hypothesis that it's really 71, right? I have to pick. I have to decide ahead of time, right? So, well, what's the cutoff? What's the general cutoff? It's 0.05, but what does that mean? I need to figure out where about 5% is. And go anything in here, I'm going to reject the null hypothesis, right? What is this concept called?
Alpha.
Alpha. Before I even collect a single person, I decide if I get any sample average for you guys in the highest 5%, I'm going to reject this 71. It's gone. No more null hypothesis.
Right.
I reject it. So let's say I calculate a 72. Right? Is that in the extreme, is that in the high 5%?
Yes.
Yes. I would reject the null hypothesis, right? What if I'm wrong? Could I be?
Yes.
But I'm still going to reject it, right?
It's a type 1 error.
Alpha is the probability of a type 1 error. Right? So, let's say I have rejected the null hypothesis. And in reality, you guys are no different from all the other classes. What have I just done? I've rejected the null hypothesis, and in reality, you guys are no different than the other classes.
Type 2?
Think about it. You have to think about it.
Oh,
I've rejected the null hypothesis. What is the null hypothesis?
that we are. That we aren't. Wait.
I know, it's hard to wrap your mind around,
What's the
right?
question? What's the
Oh,
question?
God.
If we reject the
Think
null
about it.
hypothesis,
I've rejected the null hypothesis. So what am I saying if I reject the null hypothesis?
Does
That we're no
That
different.
you guys are different, right?
Oh.
If I reject the null hypothesis, I'm saying
Oh, yes.
you guys are different.
Oh.
But now I'm telling you in reality, you don't know it. But in reality, you're exactly the same. It's a type 1 error. Yep, because I'm wrong, right? I'm rejecting the null hypothesis. In reality, the null hypothesis is true. Type 1 error. Gotta memorize those. Memorize and
You
use
can change the
them.
words and it can confuse us.
Yes. So you have to think about what it's saying. I know, so hard to actually have to think about stuff. So let's say, right? So so let's use a different example. So I'm a researcher, and I think men and women are different.
oh,
I think that women own so many more pairs of shoes than men.
You're right. But you're right.
you never
And
know.
I failed to reject the null hypothesis. Oh my. I have failed to reject the null hypothesis, and I don't know it. Because let's say in my sample, I don't get a huge difference between the men and the women that I grab. I just don't, right? So I failed to reject the null hypothesis. And in reality, I don't know it. The null hypothesis is actually false. In reality, men and women are different. What have I committed? Type 2 error.
So it's when we fail to reject the null.
So think about it. So ask yourself, if you're on the exam, your choices are between type 1, type 2 error, right? And you're trying to figure out what's going on here. Ask yourself a question. Is this person making a mistake? Start there, right? This person has failed to reject the null hypothesis, and the null hypothesis is false. Is that a mistake?
No.
Failed to reject the null hypothesis. I haven't rejected it, right? That's a decision I'm making. I haven't rejected it. I'm going with the null. I've said null, stay in bed. I'm staying with the null, right? And in reality, the null is false. I should kick it out of bed. Is that a mistake?
Yes.
Yeah. So start there. And if you're making a mistake and you're failing to reject the null, type 2. If you're making a mistake but going with the null, type 1. But do you think I might have the option on there? You're making a correct decision? Yeah, probably. So don't assume the person's always making a mistake, because here's what not making a mistake sounds like. I think that little boys are a whole lot more physically aggressive than little girls. Do you hear that? I reject the null hypothesis. In reality, little boys are more physically aggressive than little girls. What have I done? I've made a right decision. I've made a correct decision. And in fact, the probability of doing this would be power. That's right. The probability of committing a type 1 error is called alpha. The probability of committing a type 2 error is called beta. The probability of making a right decision when you're rejecting the null hypothesis is power. Now you can make a right decision the other way, not reject the null hypothesis. People are not different. That's called 1 minus alpha because it doesn't get a special name because it's really boring.
I just want to say that.
So know the definition, the formal definitions for type 1 and type 2 error. But also, no, it's not the entire test. But I'm guessing an A on the exam, if that's what you're hoping for, you're going to have to read these scenarios and go, what's going on here? Type 1, type 2 error, or a correct decision?
Power is not 1 minus alpha, is it?
No, it's 1 minus beta. Because remember, do you remember that picture I showed you with the null and the alternative hypotheses on it? Here's the null hypothesis sampling distribution, right? Why? Because it's centered on 71, right? And let's say alpha is here. This would be alpha, right? The portion of the null distribution where I'm saying I'm going to reject the null hypothesis. Even if it's true, I'm going to reject it this many times anyway, right? Okay. But let's say for your actual class you get a 72. So your alternative hypothesis sampling distribution is here, right? Centered on 72. Alpha is a section of the null hypothesis. Power and beta are 2 halves of the alternative hypothesis. Power is the probability you're going to correctly go with the alternative. Am I going to do that all this time? Anything over here, I'm going to reject the null, right? Anything over here, I'm going to reject the null. So this is power. It's to the right. Anything over here, I'm going to fail to reject the null, right? And if the alternative is the right one, I'm making a mistake, right? Beta. I see this picture in your future. Wow. It's not worth 100% of your exam, but again, if you want an A, all of these concepts are important.
And the space in between the 2 averages is the effect?
Yes. The difference between here and here is the effect.
And 1 minus alpha is...
So this is the dividing line on the null, right? This is alpha. Everything over here would be 1 minus alpha. Definitely know those concepts. The last thing, conceptually, that I think it's good, it's a little bit hard for you to wrap your head around, is what a p-value is. So you can think about these concepts as going together. There's alpha, it's a part of the null distribution. There's 1 minus alpha, it's a part of the null distribution, right? There's power, it's a part of the alternative distribution. There's beta, it's a part of the alternative distribution. But all 4 of these concepts are set by whatever alpha you chose, right? Because that alpha made this dividing line. It cut up both of these distributions. Now, what is a p-value? A p-value, to refresh your memory, is looking at this 72 and figuring out what part of the null hypothesis sampling distribution would be more extreme than 72. It's the probability of your data or data more extreme if the null is true. Let me say that again so that you could write it down. A p-value is the probability of data, your data or data more extreme if the null is true. Those 5 concepts, alpha, 1 minus alpha, power, beta, and a p-value will be on the exam. So make sure you familiarize yourself with them. But they're just different proportions of these 2 sampling distributions of the mean. That's all they are. All of these 5 concepts here are proportions. They're proportions of these sampling distributions. Technically, the p-value should be up here too. Because the p-value is also a proportion of the null hypothesis sampling distribution. And all you need is the p-value and alpha to make a decision. If your p-value is less than alpha, you reject the null.
If your p-value is less than alpha,
You reject the null hypothesis. Does anything influence alpha? Who remembers that? Anything besides you? You pick it, right? If you collect more people, will that make alpha smaller? No, because you pick it. It's 0.05, right? But there are some things that can increase power and decrease beta, right? And anything that would increase power would decrease beta. Anything that would increase beta would decrease power, right? Because they're just two halves of the alternative hypothesis sampling distribution, right? And there are some things that you can do because alpha is the likelihood of a type 1 error, right? Beta is the likelihood of a type 2 error, right? Right. So there's things you can do to minimize beta and maximize power. The only thing you have direct control over is sample size, right? More people means less beta, greater power. Now I could change my alpha, right? I could monkey with my alpha, move this line around, and that would certainly change things, but it would also change alpha, right? You're like, oh, well look, I'll just make alpha go this way. I'll make beta smaller this way, but what other, then you're increasing the likelihood of what type of error? Type 1 error, right? That's not a good way of going about it, but yes, a bigger alpha will result in less beta. More people, more power, less beta. A bigger effect size. Right, a bigger effect size would be, oh, all the way over here, I apologize. If I move these two distributions apart, do you see how that would make power bigger?
That's the effect size.
Yeah, that's the effect size, right? If I move this distribution way over there, now power is big and beta gets smaller, right? And alpha doesn't change. Why? Because you picked alpha. And alpha doesn't live on this distribution. It lives on the other one. So, and there were that list I gave you of things that increase power and decrease beta. Effect size and sample size are two of the big ones. Okay? All right. So that is the big broad strokes. Hold on 1 second though. I want to make sure.
Yes, don't forget. So,
All right. So here, let's say. Okay. So if the null hypothesis is true, every time, 100% of the time, no matter how many, let's just say it always is, because I'm the worst researcher ever. And I am terrible at coming up with research hypotheses. I'm just terrible at it. I'm always asking questions like, I don't know, are blonde-haired people, do they get different exam scores than brunette people? Is the null probably true there? Yeah, probably. I'm guessing the brunettes and the blondes are exactly the same. That'd be my guess. Or I will say, what are glasses wearers that have different exam scores than people who don't wear glasses? And I'm like, you think the null's true there, that they're probably the same? Probably. I'm just terrible. People who wear flip-flops versus high heels. People who wear X-Men shirts versus other types of t-shirts, right? I'm terrible at this. I'm terrible at this. I am so bad at coming up with research questions. I'm awful at it. So every time I do a research study, the null is true. Do you hear what I'm setting up here? Do you hear I'm starting out with the assumption the null is true? That's always the assumption, right? But let's pretend that it always is. And let's say I do 100 research studies. Do you hear that? Every single time the null is true. And I use an alpha of 0.05. How many times am I going to reject the null anyway?
0.05.
How many times?
100 times. 90.
Infinite amount.
I've done 100 research studies. Each one worse than the last. Are blondes different than and I have this null hypothesis, right? Blondes are different than brunettes. Okay?
95.
How many times am I going to reject the null hypothesis?
0.95.
95% of the time I'm going to conclude that these people are different?
5%.
5%. 5% of the time I will. So how many times am I going to reject the null hypothesis anyway?
0.05.
Is 0.05 a number of studies? 5 times. That is a particularly challenging example of some of the very small number of hard questions on the exam.
Wow.
And that's it.
So essay questions.
And that's it.
And you're gonna upload this onto Moodle
Yeah.
by today?
Yeah, I'll do it right now.
So.
Well, probably later tonight, but I will.
Okay.
And what I'll actually upload it to you is to a YouTube link. I don't know who saw this for the first exam. I did this for the first exam. I uploaded the honors review.
Oh.
Oh yeah, I did. So, and I'll do this for this one as well. It's a YouTube link, so you'll have to be comfortable going to YouTube. It's my channel on YouTube. You can watch my biopsych exams too.
Oh, I'm so sorry.
They're always there.
Yeah, my videos are always there.